Students also need to know what if I give you a scenario and I say I have a bar magnet and I'm moving the north end of a magnet towards another magnet and it repels. You need to be able to tell me, is it repelling against the north end of the other magnet or south end? And vice versa. If I'm holding a south end of a magnet and it attracts, what end is that other magnet? So you're going to have to use your thinking skills to deduct and to make sure that you understand that. So we know that like poles repel or repulse and opposite poles attract. So use that information to help guide your thinking through that question. We're going to learn for electromagnets that the more coils we do, the stronger the electromagnet. The less coils, the weaker. So there's a multiple choice question on that. You are also going to need to know that iron, like a nail or something, is going to make an electromagnet strong. We know that magnets are attracted to iron or steel, so it is going to make it strong. You're on the test, you're going to see a bar magnet with a north and a south pole. You need to tell me where on that magnet, circle where on the magnet it's the strongest. This was demonstrated and practiced in class when we had the iron fillings that were loose, and students noticed that the iron fillings were attracted to the ends of the magnet. That's because the poles are the strongest. And so everything is attracted to the poles. So you're going to have to clearly write that in a complete sentence and circle the poles of the bar magnet. There's a scenario where students are starting a recycling program and they have tin cans out of steel with like vegetable cans, and they have aluminum cans. And you're going to have to tell me how they should sort those. Since we are talking about magnetism, be careful not to sort them by color or size or height. Try and stick with the topic of magnetism. If you're doing a magnetic experiment with those cans, how would you sort them? And finally on the test, students today in class, we did an experiment called break the force, where they had to put the number of spacers to break the magnetic force. And students had to graph that information. Just like we did in class, students will get information from a chart and they're going to have to graph it. They're going to have to remember to put the title down. They're going to have to put label the axis, put the intervals, the scale, and what they're going to see is that a student has one magnet and it could pick up so many paper clips. A student has two magnets and it could pick up a little bit more paper clips. 3 magnets and it could pick up a little bit more paper clips. So students are going to have to graph the information that is given to them clearly and specifically with all of those parts. So that is it for the test. I hope they study well. We're going to go over the whole study guide on Wednesday, including the graph information, and we're going to talk more about electromagnets on Tuesday and Wednesday as well. So let me know if any questions. Have fun studying. I think y'all will rock the test. Just think about the experiments we did in class. Bye. Or how many paper clips can it pick up? What if you use 4 batteries? So you need to make sure that you're using your quantitative data and that it's going up in numbers. As you add batteries, the force is stronger. The strength is stronger. You will also need to think back to Mystery Bear, and we talked about what an observation is. An observation is something that you see. I see a blue hat. I see brown liquid. And then a inference is something that you could say based on your observation. So you could say if you see a brown liquid and a blue hat, you could infer that somebody might have been drinking a soda. The other thing is that you need to know, so someone's going to say a statement, and you need to make sure that you can say, was it an observation? Was it an inference? Or was it a prediction? A prediction is just a wild guess. An inference is an educated guess based on your observations. You also need to know what is quantitative and qualitative data. And it's just like the word sounds. Quantity is how many. So quantitative data will always deal in numbers. Qualitative data will always be, what can you observe? Is it foggy? Is it clear? Is it liquidy? Does it look like a gel? What color is it? Quality of things, the hue, is it murky? There's going to be a graph on the test with an X and a Y axis based on an electromagnet. Students need to understand that for an electromagnet, you need to know how many batteries, and that will tell you how much it could lift or how much can be attracted to it. So there's only two components, the number of batteries and the mass lifted. You also need to know